Hello everyone, it's May 29th, it's a Saturday, which means most likely we're going to have a difficult question. Alright, I think I'm ready for it. Let's see what we're going to have. Alright, first check this. I don't think anything of concern. 3, 2, 1, take a look. Oh wait, I got into April. Sorry, I got it wrong. I didn't see anything. Alright, this is May 29th. Alright. That they do this intentionally, right? They definitely do this intentionally. Queens again. Alright, remember how we did the last time? Yeah. We have diagonals. Diagonals have the same property. Rows and columns have the same property, so we can just basically search. And yeah, I think I kind of remember how we did last time. All right, the problem placing return the number of distinct solutions to the n-queens puzzle. Oh wait, isn't this the same? This is the same, right? I mean, last week is to provide to print out everything, and this time is just to return the number of solutions. I think we just need to write n-queen again, and yeah, we just need to write n-queens again and count how many unique solutions there are. Distinct solutions. Wait, are there like not distinct the way that we do last time? I don't think so, because at each queen we go from like place by place, right? We go place by place, and then every time if we can reach a solution, and the next one will be different. So I think it's the same thing. We'll give it a shot. We'll see if it's the same thing, right? If it's the same thing. But for sure is we have to write n-queen again. Well, we just did it last week, so I hope that I am still remembering it right. It's backtracking, that much I remember. And it's backtracking, and it's also we use the little trick. I shouldn't say it's a trick. It's just the way how it is, right? So what I remember is we're gonna create. I'm gonna create a board, right? Hold on. I remember there's not even a board. I think it's just the location, right? The position of the queen at each. Yeah, so I think it's just the position of the queen at each position, right? So what? I actually forgot. So we have the positions, right? Positions on the column, and we're gonna have 3 sets. One is for rows. We don't have the rows. We just need to go columns, right? This is gonna be a set, and diagonal. I remember diag, and the other one I call anti-diag. So diag is gonna be let's call it left to right. Diag, anti-diag. So a diag is the left to right. Not left to right. It's just the northwest to southeast, right? And then we'll just call it D1 and D2. D2 is also a set that is going to be northeast to southwest, right? And then we're gonna say we're gonna have a set, a list. So the def backtrack. I'll call it backtrack, right? Backtrack. backtrack. We just need a current queens, right? Queens can be a list of integer. We're gonna now return. We're gonna return anything? No, we're not gonna return anything because we're gonna put the result as a this, right? So, and also we need the int, right? So when we say if row equals n, right? If row equals n, then we say res 0 plus equal 1. So we don't even have to print it out. Else, then we say at a current row, we're gonna go one by one. Let's say for j in range n, right? J in range n. J in range n. Then we're going to say the current is going to be row as it's a column, row column, right? So we're going to say if column is in columns or row plus column, right? I think that one diagonal is it this one's row plus column, right? 0, 0, 1, 1, 2, 2. No, that's a row minus column. That should be this one. 0, 1, 2, 3. This is 3. 0, 0, 1, 2. Yeah, so this is the plus. This is the minus. So we say if this is in parentheses, so we say if this in D1, no, actually this is going to be D2, or row minus column in D1, continue, right? If this situation happen, continue. Else, then we can put the queen here. So we say queen start append. We just need a column. We don't even need the queen because we are not producing, right? We're not producing anything. Like we don't need the final result. So I don't think we need a queen. If it's possible, then we say columns dot add column, right? D1 dot add row minus column, D2 dot add row plus column, right? And then we call it backtracking again, row plus 1. Yeah, I don't think we even need the queens because we're not producing the final result. We're just checking how many we have. So we do this, and after we do this, we need to backtrack. So we got remove column, D1 dot remove row minus column, D2 dot remove row plus column, and then go back and check the next column. And when we're done, we're going to say backtrack, start from row 0, and we're going to return res 0. All right, give it a shot. I think we have 4 should give us 2. 1 should give us 1. All right, this is going to be, no, this is going to be n. And the total n queens, n. Run it. Okay, we pass. We pass both. Yeah, I think this is correct. Well, it is going to be a tough question, but I think we just got it because we happen to have done it last week. So we know all the tricks, right? We know all the tricks. Yeah, so it is, if like, I mean, I think this is easier than, because you don't have to keep tracking of the queens. So this is I think it's an easier version, right, of the original n queens, because we are not required to output the actual solution, which means we don't have to track the positions of each queen. That said, the idea is exactly the same as the previous queen problem. We just increment, right? Increment a result, increment a counter once a solution is found. Since each solution always corresponds to at least one unique queen position, all solutions are unique. In other words, when we enter the condition of when we find a solution, there is no need to check for uniqueness. So total runtime is O(n) squared because no, I think we said it's not O(n) squared because I think it's O(n) factorial because the first position we have 4 positions, right? And then the next one we have 2 positions, and the next one we have n minus 2, n minus 4, and then we do multiply them together. I remember it's O(n) factorial. What's our runtime? Oh, and also, yeah, also the same trick of using sum of the row and column indices, sum and difference of the row and column indices to represent diagonals. And the same trick